Let's do part A. So here we find the domain of this function, that is g minus f of x. So when we use the algebra of functions rule, we can write down this as g of x minus f of x. So this is basically a subtraction of two different functions, that is g of x and f of x. Here the domain is the union of these two different functions. So the domain of this g of x is this is basically a quadratic function. A quadratic function is defined for all real numbers. So the domain of g of x is all real numbers, and the domain of f of x, which is 4x plus 8. So this is a linear function. The linear function is also defined for all real numbers. So the basically the domain of this g minus f of x, which is subtraction of these two functions, is the domain is the union of the domain of these two individual functions. So we can say that the domain is all real numbers because there are no restrictions for the individual functions. Clearly, the domain is all real numbers, or in interval notation, we can write down this as domain is from negative infinity to positive infinity. Now let's simplify this function, that is g minus f of x. This equals, I'm going to substitute g of x and f of x. G of x is x squared minus 4 minus f of x is 4x plus 8. So let's simplify this. We get x squared minus 4 minus 4x minus 8. Now I can write down this as x squared minus 4x minus 4 minus 8 is minus 12. So this is g minus f of x. Let's do part B. So here we determine the domain of this f by g of x function. And when we use this algebra of rule, this can be written as f of x over g of x. This is basically a quotient of two different functions, f of x and g of x. So here to determine the domain is all real numbers except the denominator equals 0. So which means we have to determine the domain of g of x, and we have to determine the values of x where it is not 0. So I'm going to consider only the g of x, that is g of x equals x squared minus 4, and determine at which points of x it is 0. So I replace g of x equals 0, and this equals 0 equals x squared minus 4. This implies 0 equals, if we use the difference of squares, I can write down this as x plus 2 times of x minus 2. So basically this is 0 at x equal to negative 2 as well as at positive 2. So when x is negative 2 and positive 2, the g of x equals 0, which means we have to exclude these two values from the domain of g of x. So we can say that the domain of the complete function is basically all real numbers except these two values, that is negative 2 and positive 2. Or otherwise, in interval notation, we can write down the domain as starting from negative infinity. We will have to go till negative 2, then union between this points, that is negative 2 comma 2, then union 2 to positive infinity. So in this interval notation, it clearly indicates that the domain is all real numbers except negative 2 and positive 2. So this is the domain of this f by g of x function. We now simplify this function. So f by g of x equals f of x over g of x. So I'm going to replace f of x, which is 4x plus 8, over g of x is x squared minus 4. Now I can simplify the denominator terms. So this I'm going to factor 4 from the numerator part. That is, if I factor, I will get 4 times of x plus 2. And using the difference of squares, the denominator can be written as x plus 2 times of x minus 2. We now cancel out the common terms from the numerator and the denominator. This x plus 2 and x minus 2 will get cancelled. So finally, we are left with this expression, that is 4 over x minus 2. Therefore, f by g of x equals 4 over x minus 2.